Hi guys, you welcome back to my channel. Today we want to take a look at a particular video based on request from one of our subscribers at University of Nsukka, that's UNN, here in Nigeria. She messaged me yesterday, sir, I will need a video on stoichiometry under chemistry 101. So today we want to take a look at the part 1 of the stoichiometry, but before then I would love to explain more about this stoichiometry. What do you have on the board? The word stoichiometry is coined from two words, stoichion and metron. This particular one, we can say this one is atom, while for this is measurements. Is that clear now? So if you want to look at the definition of these two, it deals with chemical calculation based on elementary particles of matter. Is that clear now? Because if we are to take a look at this stoichiometry, we also make it clear that for every stoichiometry there must be what? Atom as well as what? Measurement. If this one does not exist, nothing like what? Stoichiometry. And one thing you should know is that they deals with chemical calculation based on elementary particles of what? Matter. How does that relate to what we are talking about stoichiometry? So I'm going to add this to it based on the highlight relationship between the composition and the chemical reaction of the matter and its mole. So based on highlights of relationship between the composition or the chemical calculation of particles of matter and its mole. Look at these two that I underlined here now. We want to take a look at matter and its particle. We all know that matter is anything that has mass and volume. That is my own definition of what matter. The general definition of matter states that matter is anything that have mass and can what? Occupy space. Me standing at the front of the camera here, I'm occupying a particular space here, so I can easily say that I'm what? A matter. Is that clear now? So how does it relate to the relationship between the composition and its mole? It is very simple. And one thing you should know about this stoichiometry as an undergraduate is that you need to understand what does moles entails. And if you observe here, I made mention of atom as well as what? Measurement, matter, and what? Its mole. So the next one to take a look at now is mole and its relationship. Moles and its relationship. So how do we tackle something like this? When we talk about moles and its relationship, is that we want to take a look at how does mole have effect on stoichiometry. So guys, let's take a look at that. The first formula is number of mole equal to mass in gram over molar mass in gram per mole. The second one, number of mole equal concentration in mole per dm cube multiplied by volume. We also have another one, So this each formula here, this one talk about the relationship of a given masses. Why this one talk about for solution? Because you're having a what? A volume here. So one thing you should know is that according to ideal, because moles have effects on ideal also, so we can say for ideal gas, for ideal, you can say we have PV equal to nRT. Note one thing, under gas law or under the gas and its relationship, our R is always 8.314, but here R is given to be 0.082 mole per Kelvin, because we have this N here, the number of mole. Our R is this, T, P is pressure, while V is what? The volume. So we have what here? Joule. Is that clear now? So the next one I want to take a look at is that if you are given a particular formula which relates to volume, I'll be showing you guys that one also. So we'll take a look at the number 4 at STP. So we can easily say N is equal to volume occupied over 22.4 dm cube. So when we talk about this one, it's talking about the relationship between standard temperature and pressure. Is that clear now? And for again, we have what we call for elementary particles. Again, for elementary particles. So number 5 for elementary particles will give us number of particles. So let's say N, which is number of mole, equal to number of particles over Avogadro's constant, which is this, particles per mole. So guys, don't forget earlier I said that if you are given a formula like this, it shows that there's a what? A given masses. For this, for solution, for this at ideal gas, we have this. While for this, volume occupied divided by 22.4 dm cube, and for this, for elementary particles, number, which is N, equal to number of particles divided by Avogadro's constant. So guys, with all what you have on the board, we are going to play with some examples under each of them. So now let's take a look at this example 1. It is stated clearly that if we are to look for the molar mass of each of the following. So how do we calculate the molar mass of each of the following? Looking at what we have on the board here, we are not asked to what? Make use of number of mole. No. We only have to look for what? Molar mass, which you have the unit in gram per mole. But no one thing, as an undergraduate, you'll be given the atomic mass, or we call it relative molecular mass of each element. On this question we don't have it, but as an undergraduate you need to memorize the atomic number of the first 20 elements, or better still the first 30 elements, then as well as the what? Atomic mass. So now for H, Cl equal to 35.5, oxygen is 16, sodium we have 23, sulfur we have what? 32. So now these are the atomic mass of each of the elements. So let's play with the first one. HCl equal hydrogen plus what? 35.5. So we have what? 36.5 gram per mole. B, we have glucose. So note one thing, if you are given a question like this and you are the type that you don't know how to simplify each of these things, okay, I did not state for carbon, so let's put that. Carbon is what, class? 12. So what do you have here for the subscript? You have 6. That will be 12 multiplied by 6 plus, everything is what? 1. 1 multiplied by 12 plus 16 multiplied by 6. So we can say we have 12 times 6. We have 72 plus 1 times 12 is 12 plus what? 16 times 6. We have 96. So let's add up everything. Plus 12. So we have 180 gram per mole. Don't forget to always add your what? Your unit. The last one, which is Na2SO4 sodium sulfate. What is our sodium? We have 23 multiplied by 2 plus this, we have 32 plus 16 times what? 4. So we can say 23 times 2, we have 46 plus 32 plus 16 times 4, we have what? 64. So let's add up 64 plus 46 plus 32. We have 142 gram per mole. So guys, do justice to those of you, because for every topic in chemistry you need to have the background knowledge before we can move to the complex part of the stoichiometry. That's why I said clearly that we'll be looking at the stoichiometry 1. Is that clear now? So let's take a look at another example which you can easily pick either any of this formula here, in as much as we are familiar with how to calculate. Guys, this is the second example which we are going to play with each of what we have on the board. First and foremost, what is they said, calculate the number of moles present in each of the following. The first one is 5.3 gram of sodium carbonate. So now you can say it, the first thing we are going to do, we have to look for the molar mass, because we are also look for the what? The number of moles present in each of the following. So now we are going to take a look at the formula under the mole and its relationship. Is that clear now? So you can say 5.3 gram is equal to what? Mass. Then what would be the molar mass of sodium carbonate? So it's very simple. Sodium is 23 multiplied by 2 plus 12 for carbon plus 16 times 3, so 46 plus 12 plus 48. So let's take a look at the addition of the 3. 46 plus 12 plus 48. So we have 106 gram per what? Per mole. So we are going with this formula. Is that clear now? So it said number of mole equal mass in gram over molar mass in gram. Please always take note of the what? The unit. So it said number of mole. What's our mass given? 5.3 gram divided by 106 gram per mole. The gram will what? Cancel the gram. Don't forget we are looking for the what? So you can say 5.3 divided by 106. So we have 0.05 mole. So if you are an undergraduate, please don't panic. The topic alone under your syllabus will make you what? Fear. No. When you go through the what? The syllabus, you find out that most of the topics there are things that is more a little bit advanced to what you have done under your what? Your secondary school, maybe from SS1 down to SS3. So take note of this now. So number 2 states 200 cm cube of 0.005 0 to 5 mole per dm cube HCl solution. So please take note of this now before we take a look at the what? The B. So B. So now, before you can do anything on this now, let's take a look at the formula we have on the board. If you observe vividly, we are given in mole per dm cube, but the volume, we have to look for it. So how do you look for the volume? So just write the formula by saying number of mole equal concentration in mole per dm cube multiplied by what? Volume. So it is very, very what? Simple. You can say 200 cm cube over 1000 cm cube dm cube. Are you getting it now? So the first thing we are going to do now is that how are we going to have our answer in mole? The same one thing you should know is that 1 dm cube is always equivalent to 1000 watts cm cube. So with that, you can set this divided by this. What are we going to have? 200 divided by 1000. We have 0.2. So we have what? 0.2 dm cube now. This is gone already. So by saying said 0.025 mole per dm cube of HCl solution will give us what? 0.2 multiplied by dm cube, or better still, let's start with what I have what? Mole per dm cube. 0.025. Don't forget the formula, number of mole, which is this. So mole per dm cube multiplied by 0.2 dm cube. This will cancel this. We are left with our what? Mole. So we can say 0.025 multiplied by 0.2. Okay, we have 0.005 mole. That is what? Our answer. You can see that when it comes to stoichiometry, you need to tackle each of the question according to the formula. You don't just solve any question under the stoichiometry, solve it anyhow. If you are the type that you jump into question when it comes to chemistry calculation, which is the physical aspect of chemistry, the moment you jump into that question, you also what? Jump back, because you don't know what you are going to what? Meet in the question. So let's take a look at the third one before we look at the last one. So C. .25. So this C. So now they said at STP, the formula is what? Mole. Let us say mole at STP, because I'm looking at the relationship. So that will give us volume occupied over 22.4 dm cube. Please and please, the volume occupied here is what class? 16 dm cube. So if you have to solve this now, to be 16 mole at standard temperature and pressure dm cube divided by what? 22.4 dm cube. So let's take, so we have 16 divided by 22.4. So our answer goes there. So we have 0.7 mole. Please, if we are looking at the relationship between the mole, so don't jump into the question if you don't know the kind of formula you are going to what use. So it is stated clearly that this is a part of the stoichiometry part 1. I will also be dropping the part 2, which will be looking at the complex part of this. Without this, we can't tackle that of the stoichiometry part 2. So now let's take the last one. So we have B, okay, this, instead of writing it, 4.25 atoms of copper. She said number of atoms, solution of copper is what class? 4.25 times 10 is power what? 21. We are going to make use of this number of particles. You know, when I state the definition, I said it deals with chemical calculation based on elementary particles of matter. This is now. So our Na, Avogadro's constant, is 6.2 times 10 raised to power 23 particles per mole. So with that now, our formula is what? Number of particles over Avogadro's constant. So now, number of particles is given to be 4.25 times 10 raised to power what? 21 over 6.2 times 10 raised to power 23 per mole. Because if we are solving it and we are not adding the units, how do we arrive at our answer? Is that clear now? So don't forget, let's put it for elementary particles. The same thing here for elementary particles. So now let's punch our calculator. I will advise you, if you have to solve a question like this, is that clear now? Because this will be coming here for us to eliminate this minus sign here. So we have to divide this and this. By doing that, we have 4.25 divided by 6.02. We have any 0.06. Then 10 raised to power this 21 minus what? 23. So when you start with what? 7.06 times 10 raised to power this times what? 10 raised to power what? Minus 2. So this coming here, we are having 7.06 times 10 raised to power minus 2 minus 1, and that will give us what? 7.06 times 10 raised to power minus 3 mole. So this is how we tackle a question under the stoichiometry with respect to what we have on the board. If you are given a question under the ID gas, you all know the parameters. For the stoichiometry, you will only be asked to calculate the number of mole, because under this particular topic I took today, I only specify that I'm taking what? Mole and its relationship. Guys, don't forget to subscribe to Chemistry Core channel, like, share. To the students out there who are also an undergraduate and you are given this kind of topic under the stoichiometry or under your Chemistry 101 course outline, this particular video is for you. Don't forget to drop anything in the comments